Hey everyone, welcome back to the channel. In my predicted California housing prices video, uh, we built a machine learning model to predict California housing prices. But guess what? We can do even better. Today, we will improve our model accuracy using XGBoost, which is one of the most powerful machine learning algorithm. And by the end of this tutorial, we will push our R squared score even closer to zero point 0.9. If you are new here, so don't forget to hit like, subscribe and comment below if you have any question. So in this video, we trained a model but our R squared score was around zero point 0.8. So that means our model only explained 80% of the price variations. So we want to get it as close as possible to zero point 0.9 for more accurate predictions. So to do this, we will use XGBoost Extreme Gradient Boosting, a highly optimized version of gradient boosting that delivers state-of-the-art performance. So in our previous video, the R square scored error is zero point 0.8, which is 80%. So add a new cell. So first we need to install the XGBoost. If you haven't installed it yet, then run the uh, code pip install xgboost. So I already installed, but for you guys I am again installing this xgboost. As you can see, requirement already satisfied. So after this, add a new column. Now import the necessary library. So from xgboost import xgb regressor xgb regressor. Okay, now after this, from that's it. We already import in our last code R2 score, which is already imported. Okay, now let's initialize our XGBoost regressor with optimal hyperparameters. So add a new column, new cell, initialize XGBoost with the optimal hyperparameters. Okay, so xgb underscore model equal to xgb regressor. Now it will get a few arguments. So n underscore estimator, which is equal to 300. Now comma learning rate, which is equal to 0.05, comma max depth equal to 10, and random state equal to 42. Okay, now after this, uh, train the model. So xgb underscore model dot fit x underscore train scaled and y underscore train. Okay, so what do these hyperparameters mean? N estimators equal to 300. It means a number of decision trees. Learning to equal to 0.05. It controls how much the model learns from each iterations. And the third one is max depth, which is equal to 10. So maximum depth of each tree, preventing overfitting. And the last one is the random state equal to 42, which ensures reproducibility of results. So these setting balance performance and accuracy. Okay, our next step is, uh, now that our model is trained, let's make predictions and check how well it performs. So for this, y underscore prediction underscore xgb equal to XGB model dot predict. So here we use the x underscore test scaled. Now evaluate the model. So for this we use r2 underscore xgb equal to r2 underscore score. So it will get two parameters. The first one is y underscore test and the second one is y underscore predict xgb. Okay, now print the message, which is a formatted string. So here we use xg boost r squared score and r2 underscore xgb. Remember, if you run these cells, so before this you run all the code from the beginning. So run the first one and this one as well. Okay, now after this data pre-processing, now after this training the model, which is a random forest regressor, and this the r squared result is 0.8, so it will take some time. As you can see, r squared error is 0.80. Okay, now install this. So I already installed, I am commenting this. Now run this cell. After this run this one. Okay, so cut this code and paste it here. Again run this code. So here you can see XGBoost R squared score is 0.835. It's mean uh, in our previous model we got an R square score of around zero point 0.8. With XGBoost or R square improved to approximately 0.84. So this means our model explains even more of the price variations, making it more reliable. So the more accurate our model, the better predictions we can make for real world housing prices. Why XGBoost works so well? It automatically handles missing value. It builds multiple trees in parallel for faster computation. It uses a technique called boosting, improving model accuracy step by step. It can handle large data sets efficiently. So that's why XGBoost is widely used in real world machine learning competitions like Kaggle. So if you want to push our R2 square score even higher, so try feature engineering, create a new features like rooms per household, hyperparameter tuning, optimize the number of estimators, learning rate, etc., staking model, combine XGBoost with random forest or ride ridge regressions. So let me know in the comments if you want to follow up video on these topics. Okay, so the question is why we are not getting close to the zero point 0.9 r square. There are a few reasons, so I will make a video on this issue, why we are not achieving to zero point 0.9 r square. So if you found this video helpful, smash that like button, hit subscribe and drop a comment below. Let's keep learning together. Stay tuned for more Python and machine learning tutorials. See you in the next video.